So before we uh, simulate a, let's say, mini internet, what happens? I think we need to clarify a few more concepts when it comes to the operation of the routers and the significance of the internet layer or the network layer. So this is the uh, uh, network we have already created when discussing about routing. So let's try and change it a bit to understand why the network layer or internet layer is so important. So let's change this network to a Wi-Fi network and change this interface to some other link instead of Ethernet. Let's change it to some other link, maybe fiber optics or maybe what you call as serial links. So and see what happens then. So let's start with this. This switch is there. That's fine. Skip the switch. We'll change this to. We already discussed how to set up a fiber wireless link, but let's go ahead again. Let's switch this off. Configuration. Okay. This is the module. 2.5 gigahertz wireless module. Let's put it here. Okay, before we should remove this, put it here. And then switch on. Similarly, now go to config 10.1.1.1 and this wireless. We don't need to do anything here. Let's 10.1.1.2 and 255.255.255.0. So that should do it. Let's see. Yes. Similarly, switch it off, take this off, config. So wireless. Let's put it 10.1.1.3 .0 and we will default gateway. So that should do it. So we have included a wireless module, wireless network interface card in our PCs and remove those Ethernet modules. Now we can use say one of these wireless access points. So we'll use this one. This one is one of the easiest. So it automatically connects. Anyhow, we'll use these two. Okay, let's put it here. Let's put it there. Fine, no issue. Let's make this a little bit more good looking. Fine. So these are the access points, let's say. Oh, let's configure these access points first. So port 1 is the wireless. It provides a wireless medium. We'll give no authentication. I think we'll keep this SSID as default. If you want, you can change it. You can make it default 1, default 2, whatever you want. Okay, if you want, let's make it default 1. Then port. This is the port. So this has a Ethernet port to which you can connect to a switch. We already discussed it. Make it full duplex. Similarly, config port 1. Let's make it default 2, and port 0, let's make it full duplex. Do I need to do anything here? No. Fine. So now let's connect. So they are connected. We have to connect now these PCs to these access points. So is there any other important thing missing? Settings, interface, port, is there anything missing? No, there is nothing missing, I guess. So let's connect this. How will we connect? If you remember, go to PC wireless, connect, refresh. So this is default 2, this is default 1. Okay, so let's connect to default 2. Yeah, and similarly desktop, connect, refresh, default 1, connect. So you get it. So these two PCs, let's say in a university, two different access points are there and two different people are accessing the same network through two different access points. Finally, they get to the same switch. This is the entire network. This entire network, including this interface, is 10.1.1.0. This is 10.1.2.0, and this is 10.1.3.0. So now let's change this interface. So this is a Ethernet interface. Let's change it. So this router, let's go to this router. You see there are 3 gigabit Ethernet interfaces are there. 2 of them we were using previously. Now let's use, okay, I think we have to switch it off, switch it on. What is this module that we do? It is something called as provide a serial interface. What that is, you can read just like you have on your own, just like you have Ethernet interface, fiber optic interface. This is a serial interface. It uses different protocols in the physical layer and the data link layer, as we'll see. So this is how the whole internet is. Different networks are using different kinds of links, the physical layer particularly, and different protocols are being used. And on top of that, that is why you need a what is called multi-layered protocol stack. The higher layers provide a common ground, a common functionality, which allows the lower layers to be flexible and change their protocols and so on and so forth. So we have done that. Similarly, let's switch this off, config, sorry, let's put this module, turn it on. Now, as you know, if you see here, we now have this. We want to now get rid of this 10.1.3.0 network from the gigabit interfaces, Ethernet interfaces. So first, let's do one thing. Let's shut the interface. Configure terminal, interface J0, I think it's 001 if I'm not wrong. Yeah, 001. 0/0/1. We'll shut it off. Shut off. So administrative down. And we will also remove the IP address from it because we want to give that IP address to a serial interface. Okay, we will do that. So similarly for router 2, this is router 0, or sorry, router 1. We'll come here, CLI, we get terminal interface G0/0/1. We want to shut it down. No IP address. Done. So these two are there. Now we will connect. Let's say we have already installed the physical hardware, serial interfaces. We'll connect the serial interface of these two routers instead of Ethernet. In fact, let's the same thing. You can use this or this, does not matter, both are serial, but it's up to you. There are slight differences in the technologies, but that's not the important part of this lecture or video demonstration. So this is now the network. We need to give the appropriate IP addresses to the network, to the serial interface. So interface S010, and we can manually configure this. Configure IP address. Configure IP address will give what 10.1.3.1 with mask off. You can do in the GUI interface, but this is the command that you can use there. So that's it. Now we can again, I'm not sure whether routing protocols are still working. Let's again configure router RIP. And what will you do? Network 10.1.1.0 is there, and network 10.1.3.0. These two are connected. So similarly, okay, now we have to give IP addresses. So interface S, so we'll give IP address 3.254 255.255.255.0. So, and again, let's see router RIP network 10.1.2.0 and network 10.1.3.0. So we have configured this. Let's see. Yeah, serial is now there. Serial interface is up with the network address provided. IP address provided. Similarly, IP address has been provided to this. Okay, so now the rest is the same as before. So now let's try to ping from one PC to the PC in a what is called wireless network. From a PC in a wireless network to a PC far away in a wired network. These networks are connected by routers. These routers are using a different interface. Here, a wireless interface, which will have 802.11 in the data link layer. These are all Ethernet interfaces. They will convert it to 802.3. This, there will be a completely different what is called data link layer protocol being used. And then again, this is Ethernet interface. So let's see what happens. So let's, okay, wireless, okay, maybe we should, are these IP addresses properly set? We should check. Okay, seems like we need to provide the IP address 10.1.1.2 at 0. Fine. Then what happens? Well, we have static 10.1.1.1. Yes, so done. Similarly, we can do for this 10.1.1.3 255.255.0 and default gateway is 10.1.1.1. Let's see if it's 3. Yes, so default gateway is this interface of the router, and we have, so let's try to ping. We'll turn on simulation mode from here. Let's try to ping here. So stop on prompt, let's say ping 10.1.1 point, not 1.2 point, let's say it is 2.3, and we'll do it 3 times. Let's see what happens. So once again, an ICMP packet, we don't need to talk about that, but as soon as the ICMP process starts, it knows that it does not have the MAC address of the this PC, this destination IP. So it starts ARP. So source and destination remains as it should be. Then ARP comes. Again, you see source and destination remains the same. It is not using IP. It is using ARP in the network layer, and it is going to use 802.11 or Wi-Fi in the link layer or data link layer, and it has provided all Fs to flood the network in pursuit of finding out whose IP address is that 10.1.2.0. So anyhow, it floods it. So let's go. It sends it on that interface. The switch floods it everywhere. It is the router, but the router does not flood the link layer frame. Router will not flood it because in order for the router to flood it, it should be in the same network. It should be a broadcast address at the network layer. A network address of 10.1.1.255 has to be given. Then it will flood in the network. It will not forward packets to any other network, no matter what. So now it goes back. So this guy learns that if I have to send it here, I must use this MAC address. The MAC address of this is 5C01. If you remember, keep in mind 5C01. So let's see what it has put. 5C01. And there are these other addresses are there. You should look into it because 802.11 is a little bit complex because it uses acknowledgement in the frame level. We'll talk about this again. In the frame level itself, it has to use acknowledgement because wireless is a very unreliable or not a very secure medium. These access points are more like hubs. So it uses acknowledgement at frame level. But in case of wired medium like Ethernet, you will not have acknowledgements, no sliding window protocol, and so on and so forth. But moving on, so now this is the address being used. It goes here. This ICMP packet. It reaches here. Inbound packet. Outbound packet. Now let's see what happens. See, this packet from here, it's converted now to an Ethernet packet with the destination of the default gateway MAC address, which is the default gateway MAC address. This is the default gateway, and that's MAC address is put there. So you will see, where is it? You will see that in this entire process, this destination IP address, source IP address has not changed. The source IP address of the ICMP process remains the same, and the destination IP address also remains the same. However, this source and destination IP, MAC addresses, they keep changing. For example, this is not the source address of this PC. This source address is from here. In a link, in this link, whatever is the source and destination address, that is being flooded. This is the MAC address of, this link. So this is how you will see now what happens. It has reached the switch. Come here. Again, you can see. Again, you can see. Now, something completely different will go out using a completely different protocol called HDLC. HDLC protocol will be used in serial links. A completely different protocol will be used here. Inbound, again, you see 5C01. This is the inbound packet with destination what? 5C01 is the router, this one. And the source address is this C8DC. Let's see if that source address is provided here. So we'll see what probably the source address of this, if we can find it. Probably the source address is, yeah, okay. The source address is this C8DC is the source address of this PC. Destination address is supposed to be the destination address of this PC. Okay, but that is not what is being done. This acts like a hub. Whatever it gets, it floods it, it sends it to the link. From here, it checks the MAC address table and sends it, because the destination address is this, it sends it on this, and likewise, it goes on. So it reaches here. Now, a completely different protocol will be followed in this serial interface. But again, look here. The IP, the network addresses remain the same. This is the source IP. This is the network IP destination IP computer. That has not changed. So let's go forward. It traverses the link here. When it reaches here, now it does not know, this router does not know what is because it has to construct finally a frame. Even though it forwards packets based on IP addresses, it has to construct a frame before sending it on its interface. So because it does not know, it starts a ARP packet. Now, if you go initially this ARP packet, it used initially when the ARP packet was initiated here, you see 802.11 was used. But this ARP packet, it is using 802.3. It all depends on the physical layer interface. But amongst everything, all this, the IP layer or the network layer data has not changed. So let's go ahead. It sends ARP, this guy responds. So finally, so ICMP, done, done, done. It will continue like this. So 3 times we wanted to do ICMP. I think we're finished. So this is the simulation come to real time. So yeah, so first one was not possible. Generally, the first packet is lost because it gets timed out. The ICMP packet gets timed out because it has to start an ARP process, find out details of MAC address, and so on and so forth. So, but after these details have been learned by the routers and switches and everything, and then the next two ICMP messages could be correctly delivered and acknowledgement also received. So we can check here, for example, in this router, show ARP. Now you can see here in this router, its ARP table, it is only concerned about this because it has this network PCs. Okay, it is only concerned about PCs of this network. This guy pinged, so its ARP table is there listed. You will not find anything corresponding to a network that is not directly connected. You will not find any information about these PCs here. Similarly, you will See, show ARP. Similarly, this router, you will find this network is directly connected. You will find MAC addresses and mapping of IP address and MAC address of this network, and you will find definitely this network. You will not find other things. So let's ping a few more. Let's do one thing. Let's show this. Let's ping 10.1.2 dot 1. We'll do it 3 times. 10.1.2.1, sorry, we should not have. 2.1 is this, so it is pinging the router. We don't need to do that. Let's 2.3. Similarly, let's do from PC2. Okay. We could actually do it from here itself. Let's go desktop. We can ping definitely within the same network. It will not even go to the router. Similarly, let's ping from this guy, or let's say this guy. Ping 10.1 point 2. And let's ping in its own network. So it's pinging from this one to this one. So if we look at show ARP in the router, you see what's happening. I just pinged a bunch of times to show you that what the ARP information it is concerned about this router. Is concerned about 10 point all this entire network. Why is there no information about this link 10.1.3.0? Why? What's the reason? Well, let's see. Hover around here. See, serial links are not provided with any MAC address. You can set it if you want, but it is not there. Maybe it's not required. Okay. Maybe the HDLC protocol works differently because there is no MAC address for the serial link. So that's why the ARP table cannot be flooded with the mapping of IP address and MAC addresses in this link. But even though there are a bunch of times pinging has been done from this network to this network and this network to this network is carrying no information about these computers. Similarly, this router will not carry any information about these computers, but it will carry information about these computers. So again, show ARP, you can see. Two point one, 2.2, 2.3. These links. So this is how the network of networks. This is a kind of an inter-network, though we have not connected to any server and all that. But this shows how different networks using different protocols at the physical layer and the data link layer can operate, because there is a common framework in the network layer providing a common platform having the same source and destination addresses at the network layer, even though data link layer addresses could keep changing as the data or the frame travels across different links in the network. So that's all. Uh, Next, we'll try to construct a so-called campus network or a mini internet kind of, to show how exactly we access data in servers and so on and so forth. So thank you.